My name is El Baba Fakhruddin. I am from CSC branch. My topic is IR spectroscopy. First, we know the outline. IR spectroscopy principles and applications. IR spectroscopy means infrared spectroscopy. Is the spectroscopy that deals with the infrared region of the electromagnetic spectrum, that is light with a longer wavelength and lower frequency than visible light. Infrared spectroscopy is the analysis of infrared light interacting with a molecule. This is a diagram. There are divided into three regions: near IR regions, middle IR regions, and far IR regions. We see the range. IR region is 0.8 mu meters to 1000 mu meters, 1 millimeter. Near IR region is 0.8 to 2 mu meters. Middle IR region is 2 to 15 mu meters. Far IR regions is 15 to 1000 mu meters. Most of the analytic applications are confined to the middle IR region because absorption of organic molecules are high in this region. Principle: molecules are made up of atoms linked by chemical bonds. The momentum of atoms and the chemical bonds look like springs and balls. Vibration: when internal vibrational energy of molecule matches with energy of externally applied IR region quantized, molecules are absorb infrared rays. A molecule can only absorb IR radiation when its absorption causes a change in its electric dipole moment. Molecules excited from lower to higher vibration level, that is, increasing the amplitude of vibration. When infrared light or radiation hits a molecule, the bonds in the molecule absorb the energy of the infrared and respond vibrating. We see the structure: IR radiation and valenin. Molecular or vibrations. Molecular vibrations, there are two types of vibrations: stretching vibration and bending vibration. Stretching vibration is vibration or oscillation along the line of bond. Change in bond length occurs at higher energy 400 0 to 1250 cm inverse. There are two types of stretching vibration: symmetric stretching and asymmetric stretching. Symmetric stretching: two bonds increases of or decreasing in length simultaneously. We see the structure. And next, asymmetrical stretching: one bond length is increased and another is decreased. We see the structure also. And bending vibrations: vibrations are oscillations not along the line of bond. They are also called deformation. In this, bond angle is altered. OC occurs at low energy 1400 to 666 cm inverse. Two types: in plane bending and out plane bending. In plane bending also divided into two types: scrolling, rocking. Out plane bending also two types: wagging and twisting. In plane bending, rocking, crossing. We see the both images. Out plane bending, wagging: two atoms move to one side of the plane. They move up and down the plane. We see the diagram. Twisting: one atom moves above the plane and another atom moves below the plane. We see the diagram. And Hooke's law also says the single beam spectrometer and double beam spectrometer. We see the instrumentation of IR spectroscopy. First, detector, sample, exit slit, depression device, entrance slit, source. Double beam spectrometer. The double beam spectrometers are so constructed that light from the source is split into two beams of equal intensity, one passing through the sample and the other through the reference for compensation. Instrument of IR spectroscopy. The main parts of IR spectroscopy are as follows: radiation source, sample cell and sampling of substances, monochromatic chromators, detector. Infrared source. IR instruments require a source of radiant energy which emit IR radiations, which must be sufficient intensity, continuous, stable. FTIR instrument stands for Fourier transfer infrared spectrometer, the preferred method of infrared spectroscopy. Dis- dispress- Dispersive infrared spectrometers suffer from several disadvantages in sensitive, speed and wavelength accuracy. An entirely different principle is involved in Fourier transform infrared spectroscopy, which centers on a Michelson interferometer, so that the method can also be called interferometric infrared spectroscopy. We see the diagram: detector unit, lens, position of probe, mirror, probe unit, mirror, light source, beam splitter, moving mirror, fixed mirror. Applications: identification of substances. To compare spectrums, no two samples will have identical IR spectrums. Criteria: sample and reference must be tested in the identical conditions like physical state, temperature, solvent, etc. Like in industries, determine impurities in raw materials. For quality control checks to determine the percentage of required product. Identification of materials made in industries, research labs, or materials of competitors. Example: impurities beeswax with petroleum wax. And next, medical applications: hair, narcotic in hair, effect of bleaching, effect of UV radiation; skin, moisture content, lipid content, effects of cosmetics. Lastly, advantages: detection, health condition, prevention, early diagnosis, monitoring, diagnosis, under investigation. FTIR spectroscopy can be applied for the determination of a biomolecule metabolite in biological fluids. FTIR spectroscopy has been used for the determination of glucose, total protein, urea, triglycerides, cholesterol, and very low density lipoproteins in plasma and serum. Thank you for watching this video.